Hello, let's do our lesson. On this lesson, we're going to look at how we can prove the similarity theorem. How we can prove what? The similarity theorem. Remember, this theorem is examinable. You may be asked in the exam to prove this. Okay? Right. So now we may be given a situation like this, but let me just read this first. If two triangles are equiangular, then their corresponding sides are in proportion and the triangles are similar. Right. So now we're given that angle A is equal to angle P. Right. We're talking about these angles in the bigger triangle, okay, which is ABC, and then the smaller triangle, which is PQR. Okay. So we're given that angle A is equal to angle P, angle B is equal to angle Q, and then angle C is equal to angle R. Okay, and then what are we supposed to do? We are supposed to prove that AB over PQ, like AB over PQ, is equals to AC over PR, AC over PR, and equals to BC over QR. We have to prove that. We have to prove that AB over PQ is equal to AC over PR is equal to BC over QR. If the triangles are what? Are equiangular. Right. Are the corresponding sides in what? In proportion. That's what we want to prove. Right. Now, so what do we do? Remember, every theorem, you must know the construction. And also, remember the other theorems that we use. Okay. And then in this one, we're going to use congruency. We're going to use proportionality theorem. We're going to use congruency and proportionality theorem. Remember those. Right. And then the construction. What do we construct? We have to construct a side which is equals to PQ and another side which is equals to PR. So on AB, right, on AB, what do we do? We mark S to create AS which is equals to PQ. We mark S to create AS, which is equal to PQ. So we mark on AB, a point there. So it means AS is equal to PQ. Right, we're going to do the same thing on side AC. We mark T on AC to create AT, which is equals to PR. You see that? So we have AT now, which is equals to PR. And then what's the next step? And then we join ST. So now we have created triangle AST. Okay, right. What do we know about triangle AST and triangle PQR? Remember, we did construction here. We created AS, which is equals to PQ. We created AT, which is equals to PR. And we know that angle A is equals to angle P. We're given that. So we can prove that triangle AST is congruent to triangle PQR using side, angle, side. Okay, let's start with what? Let's start with the side. We have AS, which is equal to PQ. We did this through construction. And then we go to the angle, which is A there and P, which are included angles. So angle A is equal to angle P is given. And then also we have AT being equals to PR because we did what? Construction. So now we have a condition now which is side, angle, side. So we can conclude and say triangle AST is congruent to triangle PQR because it's side, angle, side. Remember the conditions of congruency. The side, 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 angle, side, angle, angle, side, and right angle, hypotenuse side. Okay, and then from this congruence, remember what information we can get. We can get that AS is equals to PQ, and we did that. Remember, we did that through construction, and then ST Now we can conclude about ST and QR. ST is also equals to QR. And then AT is equals to PR. And then about the angles also, we can say angle A is equals to angle P. That one we're given. Angle S, so it means angle S here in triangle AST is going to be this angle, which is S1 here, this one. So angle S1 is equal to angle Q. So it means it's going to be equal to this angle here. So angle S1 is equal to angle Q. And then let me highlight it. I'll highlight it now using the same thing, right? And then angle T, which is T1, okay, this T1 is equals to angle R. That's what you're getting from the congruence statement, right? So now, so we said a triangle AST is congruent to triangle PQR. So we can conclude and say angle S1 is equal to angle Q because this is what? Because of congruence. So this angle is equal to this angle. Okay? Right. Now let's go to angle S1 is equals to angle Q. Right. So remember, we say that angle Q is also equals to B. We're given that angle Q is equal to angle B here. So we're saying angle S1 is equal to angle Q and angle B is equal to angle Q. Therefore, angle S1 is equal to angle B. Okay, let me write it down. Right now, we have angle B is equal to angle Q, and then we have angle S1 is equal to angle B. Do you see that? So what does that mean? Angle S1 is equals to, oh, okay, here, from these two. Okay, check these two. We're saying angle S1 is equal to angle Q, and then angle B is equal to angle Q. So we can even write it like this and say angle S1 is equals to angle Q, which is also equals to angle B. So from here you can see that angle S1 is equal to angle B. So that's why you have this statement saying therefore angle S1 is equals to angle B. So these two angles here are equal. Angle S1 is equal to angle B. Now from if these two angles are equal, what conclusion can we make? What type of angles are they? Angle S1 and angle B. These are corresponding angles. These are corresponding angles. And then if the corresponding angles are equal, then it means the lines are parallel. If the corresponding angles are equal, means then the lines are parallel. So it means that therefore ST is parallel to BC. Okay? Remember the proportionality theorem now. What can you conclude here? So from here we can conclude and say AB over AS is equals to AC over AT. Why? Because line parallel to one side of triangle. That's proportionality theorem there. Okay. Right, but remember what we said. We said AS is equal to PQ. And then AT is equal to PR. So we can replace this with, we can replace AS with PQ and replace AT with PR. Therefore, AB over PQ is equal to AC over PR, which is this part of our equation here. So we have to do the last part. Okay, how do we do this? So we can then say similarly by construction of BS and BT on AB and BC like this. We have BS there and BT like this. Okay, right. You don't need to do the whole thing now because you've done the first part. So this is enough to say similarly by construction of BS and BT on AB and BC respectively, like what you've done, we can prove that AB AB over PQ. Remember PQ is equal to BS. Okay? Remember PQ is equal to BS. Is equal to BC over BT. And remember BT is equal to QR. You see that? So we can prove that AB over PQ is equal to BC over QR. Okay, and then now we've managed to prove that, okay, AB over PQ is equal to AC over PR. here, and then also equals to BC over what? Over QR. We proved our similarity theorem. So that's how we do it. I really hope that this will assist you a lot.